Welcome to the Gestalt IT Rundown, where each time we meet, we run down the IT news of the week with a variable degree of snarkiness. I'm your host, Stephen Foskett, and sitting in this week for Tom Hollingsworth, who's busy in California at Networking Field Day, is my good friend, Mr. Chris Gruneman. Welcome to the show, Chris.
Hey, thanks for having me again, Stephen.
Good to have you back. Can't wait to hear your take on some of the week's news. Also, I would like to point out that today is both National Salami Day and National Beer Lovers Day, and I wonder if those things were chosen to coincide.
Seems like they might have been. Speaking of salami and beer, I know they're both loved in Ohio, and an Ohio-based startup, Folio Photonics, has just announced a new, inexpensive optical technology that promises to dramatically reduce cost per bit for long-term storage. But are they making a mistake in productizing this as a 12-centimeter optical disc? What do you think, Stephen?
Yeah, that's an interesting question since this technology could be used in all sorts of different ways. Now, disclosure, I'm in Ohio and I talked to these folks, they're actually right up the road. And it's pretty exciting technology. The basic idea here is that rather than having some kind of expensive substrate to write optical data onto, what they're doing is using a extruded polymer that you basically shoot with a laser, and it kind of fluoresces once you've hit it, and then you can read it later. It's a really simple technology. Well, it's really complicated technology, but it's simple in practice once it's been invented, as are most things. And it would theoretically allow a very high density storage on a very inexpensive, flexible kind of a plastic sheet with multiple layers. It's very cool. Right out of the gate, though, it occurred to me that it was strange that they were putting it on disks, since this technology, after all, could be used in big sheets. It's produced in big sheets, and that would give you a lot more storage capacity. But the 12-centimeter optical disc, like a DVD or a CD, kind of limits the amount of space that they've got to work with. But frankly, my conversation with them showed me the wisdom of this move. Quite frankly, this gives them access to all the stuff that already exists in DVD and Blu-ray the world, including lasers, transports, motors, cartridges, manufacturing, all that stuff. And it allows them to basically get this thing to market because, as you know, the biggest challenge for any technology is not inventing it or making it work. It's typically getting it to market. So, I'll allow it. I love the idea. I love to see what they're going to do with it. And I would love to see where they go in the future with this inexpensive optical media. And heck, maybe it will prove competitive with not just Blu-ray, of course, which it's probably already going to be competitive with about out of the gate, but also maybe with tape and LTO and things like that. We'll see. Chris, you use USB, right? Are you familiar with the crazy world of USB naming? Well, guess what? USB 4 version 2.0 is here. That's the name of the latest revision of this ubiquitous connectivity standard, and it promises to bring 80 gigabit connectivity to the ubiquitous USB-C connector. I'm just going to say ubiquitous a lot. What's with this crazy name, though?
Yeah, so when we think about why not USB 5, I think we have to remember that this is the same group of folks that brought us USB 3.2 version 2x2. So USB 4 version 2 maybe isn't so crazy. And I think what they're trying to do here is signal that this isn't a radical change. It is an improvement over USB 4. And so, whether that syncs or not, I think is less important in the naming, but that's what they're signaling here, right? You can still use your USB-C cables. The passive USB 4 cables will work. There's going to be new USB 4 V2 active cables. But overall, this is a pretty cool improvement, regardless of what we call it. They're shifting to a PAM3 as the underlying signaling, which, just as kind of a refresher there, standard NRZ signaling is just the bits 0 and 1, straight binary. And then PAM4 doubles that. And so you send, something like 0, 0, and then 0, 1, and then 1, 1, which gives you a much higher bandwidth. PAM3 is kind of another strange mix in between those two, where you're actually using -1, 0, and 1. It doesn't give you quite the bandwidth of PAM4, but it does give you a considerable boost over just straight up NRZ. So that's kind of the base layer here, and that's what gets up to the 80 gig. What's also interesting though is there's some researchers from I believe it's Anantech, who found that in some specs they dug up on some testing units that there's a way apparently within the USB 4 spec to, instead of running synchronous 80 gig and 80 gig, you can actually shift this onto the transmit side and do 120 gig in one direction and 40 gig in the other direction, which is kind of cool because that allows for 8K monitors and things like that. So there's some other specifications that get tied in there and make this overall a pretty impressive version, no matter what we call it. So, Stephen, when VMware announced vVols as part of vSphere 6 in 2015, there was a tremendous amount of excitement. But the technology never really established itself as an alternative to NFS. Now that vSphere 8 is here, it might seem strange that Pure Storage is leaning into the vVols once again, but maybe the technology is finally ready for prime time?
Yeah, it's interesting because we were very, very excited. I was one of the people very excited about vVols. I mean, I did seminars where I would go out there and talk to everybody, and I was out there banging that drum that this was a cool technology. And just as a quick reminder, essentially, vVols allows the hypervisor, the vSphere hypervisor, to directly communicate with a block storage target and basically say, hey, uh, give me a fake disk, a LUN, for this virtual machine, and then do your cool stuff on that. Do replication, do snapshots, whatever it is that you like to do, Mr. Array, and I'm going to map it directly into a virtual machine. Works great, great idea, but putting it into practice actually caused a lot of headaches and a lot of hair pulling from the engineers because, frankly, a lot of block storage devices were never meant to support the numbers and the variability and the flexibility of vVol implementation. So, frankly, it has been a pretty disappointing technology for many, many vendors. But that being said, Pure Storage has always been pretty good with it. In fact, we've heard from them many times over the years at Tech Field Day sessions about how well vVols work with the flash array. And frankly, they still work. That's the cool thing. This is basically a technology that was intended to be used widely by all sorts of storage companies. And Pure is basically the one storage company that's been able to really kind of live up to the promise. And so it was interesting when we had Pure Storage present to the Tech Field Day crew at VMware Explore this year that they acknowledged this situation and basically said, yeah, we're really here in 2022 talking vVols. No kidding. And then they went on to really wow the group about all the cool things that the flash array can do with vVols. So yeah, I think that even though there is certainly a lot more excitement about NFS generally speaking, especially in the cloud and all that, frankly, a lot of systems, a lot of implementations of VMware vSphere need block storage, and Pure is really planting their flag and saying, hey, there's no beating the flash array as a block storage target for VMware vSphere. Chris, on August 24th, we discussed Qualcomm's purchase of Nuvia to produce a competitive ARM server platform, but the situation just got a lot murkier. ARM claims that Qualcomm has no rights to the new Nuvia server chip design. And it's interesting because Tom and I were pretty skeptical of the Nuvia Qualcomm server chip anyway. And frankly, this could put a final nail in the coffin, right?
It really could. And this is definitely an interesting legal situation, at least from my armchair position here. So, one of the root pieces of this whole conversation is around architecture license agreements. So, obviously, a lot of us are familiar with enterprise license agreements and the right to use software. These architecture license agreements that ARM has given out to companies are for the use, obviously, of ARM intellectual property, but then the development of new intellectual property on top of that. And that's obviously what Nuvia did here is used ARM architectures and then built on top of that, which is exactly why Qualcomm came in to snatch them up. Now, the legal ground here that ARM is trying to stand on is they're saying, hey, we granted Nuvia the rights to use our IP to build their own IP and to then sell that, but we did not grant them the right to transfer that right to another company. And so even though Qualcomm has come in and bought Nuvia, uh, ARM is claiming that the ALA does not transfer from Nuvia to Qualcomm unless ARM agrees to it. Apparently, there was some discussions behind the scenes as this merger was or acquisition was being discussed, and Qualcomm and ARM never came to terms. And so here we are. Now we're going to see this in the courts, I guess. Whether or not this, kills this off or not is, I guess, going to be down to some lawyers and some judges at this point. It's also, though, interesting that it may have spillover effects. There's another company out there that I think we might have talked about in the past, Amper, and they're doing some similar things to Nuvia in that they're building on top of an ARM ALA. And of course, if this whole thing blows up in Qualcomm's face and they cannot use the Nuvia IP and have to destroy it or whatever comes of this, that could definitely have effects for Amper being sold as well. It also has some really interesting, maybe longer term effects on ALAs in general and the power that they have. If ARM wins here, that sets one precedent, and obviously if Qualcomm wins, then ARM may be in a position where these ALAs have a lot less teeth in the future. So, very interesting to look at, both for this specific situation and beyond. CXL memory is coming, and Astera Labs is the first with a controller to pool DRAM. The Leo memory connectivity platform supports both expansion and pooling of memory using PCIe-based CXL links. Is this the start of something big, Stephen?
Yeah, I'm pretty excited about CXL. And actually, spoilers, I just recorded a checksum editorial for Gestalt IT and with a crossover with the CTO advisor on why I'm so excited about CXL. But the basic idea is that this is a fundamental re-architecting of the server. And how we get there is in steps. The first step being memory expansion. And that's pretty much what we're seeing here from Astera Labs. Essentially, their Leo platform is the first platform, really, fully fleshed out platform that lets companies build a memory expansion module that uses the CXL 1.1 protocol to expand system memory beyond the memory channels. So think about you're building a server. You used Ice Lake or AMD, and you've got 4 memory channels. You put your DRAM in there. What if you need a little more DRAM than 4 channels will hold? Well, you can either spend like 3 times as much on bigger DRAMs and bigger DIMMs and fill it up, and then have way too much memory. Or you could plug in a CXL memory expansion module on the PCI Express bus and give access to the right amount of memory. That's what we mean when we say expansion. Now, the other thing that you can do with CXL, even in the 1.1 generation, is pooling. Essentially, you could have 2 CPUs, both of them accessing the same memory region using PCI Express. And that is very, very cool for applications that shared memory makes sense for. And that's what the pooling chip does. So Astera is shipping basically the controller that allows both expansion and pooling to work. And the reason this is exciting is because, frankly, they're way out ahead of the competition. The competitors in this space are barely here with proof of concepts or FPGA based devices, and Astera is here with a functioning ASIC. Well, I say functioning, but obviously I've never touched it. It's brand new, and hopefully it's functioning. I guess that's how ASICs cut against FPGAs. So anyway, it's a pretty exciting development. It points the direction that CXL is going. Is this a revolution in computer architecture? No, but it shows us that CXL can work both for Intel and AMD CPUs. And frankly, I think that's worth talking about. So, Chris, now let's take a closer look at a story that's, I think, very important in the industry right now. For a long time, we've been talking about the restrictions on trade with countries like, China, certainly, but also Russia with the Ukraine war. And things just heated up a little bit. So last week, it was announced that export or sale of advanced GPUs from Nvidia or AMD would no longer be allowed to Russia and China. Now, of course, Russia is blockaded because of the Ukrainian war anyway. But the China thing is interesting. This is an escalation of an ongoing trade war with China. And it comes just as 2 Chinese firms have announced their own homegrown GPU designs. What do you think this means overall, I guess, for the industry in China, for the industry as a whole, and for the whole global supply chain to have, the world's largest country cut off from the world's most advanced technology?
Yeah, it's very interesting. And obviously, there's some kind of reciprocal flows here that are going to be disrupted, right? Because a lot of this stuff is, maybe it's an Nvidia chip, but it's then going to be taken to China and put into some other device that's then sold back to an American citizen. And so obviously that kind of stops. So there's some big ramifications for this. It's not just cutting China off; it's actually cutting in some ways the rest of the world off from Chinese manufacturing. And also, I saw an article that Nvidia is not the only one. I think AMD actually recently was told by some U.S. officials that it had to stop exporting its top artificial intelligence chip to China. So I don't know how official that is yet, but at least there's rumors there around the MI100 and MI250 chips. And so this is, pretty broad based, I guess, where we're taking this AI capability and trying to keep it inside the United States, which, I mean, it gets into politics and intergovernmental issues pretty quickly here. But, the question is, can the United States build the manufacturing around, these AI chips to be able to build all of the products that China would have? Or are we doing the world a disservice by cutting this off? And then the alternate side is, would China be doing something nefarious, or Russia for that matter, with these AI chips if we allowed them to continue? So definitely a far-reaching implications here and from outside technology space, I believe.
Yeah. Yeah, and indeed, I mean, it is sort of a chess game, isn't it, to try to restrict these from China. Now, of course, I suspect that China will probably get their hands on the A100 and H100 and MI250 and all of them, because frankly, it's a pretty big world, and there are a lot of trade routes out there, and also this. By the way, this rule does include the provision for export licenses to be granted on a kind of one-off basis. So I imagine that if a Chinese supercomputing lab wanted to build around H100, Nvidia might petition the U.S. government and get a license and be able to ship it anyway. So there are holes in this, and of course, it only does apply to those few advanced devices. Essentially, it looks like the A100 is being set as the limit. So they can't have anything that's A100 or greater in performance. So maybe the MI100 is okay, or I'm sorry, the MI110. Maybe the things like that can still be shipped, but the more advanced ones can't. And to me, the most interesting aspect of this, though, is that it's going to act as a forcing function on China. So essentially, China has increasingly advanced chip design capabilities of their own. And remember that the US is also acting to try to restrict chip design and chip manufacturing technology from China for this very reason. But we recently saw at Hot Chips an indigenous GPU and AI accelerator produced by a company called Biren in China. And it frankly looks like a pretty competitive platform. It's maybe not quite an H100, but it's a pretty competitive GPU and AI accelerator. And it's being built, designed and built in China. Well, where does this go? If they can produce a competitive, maybe not world beating, but a competitive GPU, maybe they don't need Nvidia and AMD in order to succeed. And maybe what they'll do is just pour development resources into things like this and end up basically creating new competition for AMD and Nvidia. And frankly, that is going to be an interesting situation because essentially the US export restrictions could end up having a much greater impact on Nvidia than just losing the potential for a number of sales of this generation of chips. It may end up, in fact, derailing some of the advanced processor designs coming out of the West in favor of alternative designs from China. So I guess we'll see where that goes. What do you think, Chris? Is that a likely scenario?
Yeah, I think so. I mean, I think we could definitely see a bifurcation of the technology landscape in some ways because potentially, because we're cutting them off, they're going to develop their own things on this other side of this wall we're building. And then, it's likely in this kind of a trade war that we would then also put a barrier to, the chips they're designing coming back over here to try and limit that competition with NVIDIA and ARM. And so you might end up having these two parallel technology paths going in two parts of the world, which um, maybe is good for diversity of technology, but sounds not so great to me.
Absolutely, and I guess we'll see where it goes. But honestly, I think that it's that's how technology happens to work. Nature abhors a vacuum, and China's going to fill in that vacuum if they can't get these chips.
Sure.
So before we go, let's take a look at what's happening in the week ahead. This week, September 7th through 9th, we've got Networking Field Day happening in warm Silicon Valley. Boy, I'm sorry to hear what's going on with the heat wave there and in Austin as well. Just go to techfieldday.com to learn more about that event. We're also going to be back on September 20th with a exclusive event, Cloud Field Day event with NetApp, again in San Jose. And the day after and the rest of that week, September 21st through 23rd, we'll be there for Cloud Field Day. So please do check out the Tech Field Day website for more information on those. Before we go, Chris, do you have anything that you've been working on or you want to publicize here?
Sure. Yeah. So myself and another Tech Field Day delegate, Zoe Rose, have recently launched a new podcast for the community. We call it the Imposter Syndrome Network Podcast. And in addition to the podcast, we've also set up a LinkedIn group for the network itself. The idea is to tell the story of various folks who work in different parts of technology to both shine a light on all the different jobs that are out there and also all the different journeys there are to get there. So if you're into career development and career advice and career growth in general, I'd love for you to check it out.
Yeah, it's really impressive so far, and a really a fun listen. So do give the Imposter Syndrome a subscription. Thank you for listening to the Gestalt IT Rundown. Remember that this show is available in your favorite podcast application, as well as on YouTube at YouTube/Gestalt IT Video. We also post the videos on our Facebook page, facebook.com/Gestalt IT, as well as on LinkedIn and Twitter. We'll be back next Wednesday to talk about the IT news of the week that was. But until then, for myself, for Chris Grundeman, for Tom Hollingsworth, and all of us here at the Gestalt IT family, here's wishing you and yours a cold beer and sausages kind of day.